One aircraft reigned supreme in the dangerous skies above the Vietnam War, the McDonnell Douglas F-4 Phantom II. Surpassing all rivals, it proved to be a masterful interceptor, a relentless ground attacker, and a cunning dogfighter. Night after daring night, soaring over the thick Southeast Asian jungles, the Phantom exemplified aerial dominance. This aircraft was not only a technological marvel of its time, but also a pioneer as one of the first two-engined fighters. Its introduction set a new standard for speed and versatility, putting the F-4 Phantom at the forefront of third-generation fighter technology. As the most produced supersonic military aircraft in history, with over 5,100 units delivered worldwide, the Phantom's extraordinary speed allowed it to cross the United States in just 3 hours. Celebrated for its vast service and unmatched versatility, the F-4 Phantom II remains a symbol of American ingenuity and engineering excellence, continuing to influence modern air defense strategies. From dominating combat in the Vietnam War to starring in the Navy's Blue Angels, no challenge was too big for the aircraft that, lacking a main gun and relying entirely on missiles, claimed over 100 MiG shootdowns. In 1953, the preliminary design stages commenced for what would ultimately evolve into the iconic Phantom II. Initially conceptualized by McDonnell as the F-3HG, this project began as a single-seat, long-range attack aircraft. This design effort was built upon the technological foundations laid by its predecessors, the F-H-1 Phantom, notable for being the Navy's inaugural jet-powered aircraft for carrier operations, the F-2H Banshee, and the F-3H Demon. Collaborating intensively with the United States Navy, McDonnell's engineering team sought to incorporate what they discerned to be the Navy's operational prerequisites into the F-3HG. This resulted in the development of the AH-1. Although there was no explicit military demand for this type of aircraft at that point, the Navy had outlined its requirements for fleet air missions, prompting McDonnell to adapt the AM-1's design to better align with these specified Navy needs. Soon, the Navy realized McDonnell's design was unnecessary, considering the Grumman XF-9F9 and Vought XF-8U-1 aircraft already covered its roles. Thus, McDonnell was forced to rework its design to become an all-weather fighter bomber with 11 external hardpoints. Fate decided otherwise, and when the company was about to incorporate these changes in early 1955, the Navy requested the design to be instead tailored as an all-weather fleet defense interceptor. As a result, McDonnell's design had to incorporate a second crewman to operate the radar and relieve the pilot of distracting information. The Navy's requests soon materialized in the F-4H-1 design. The aircraft carried 4 semi-recessed AAMN-6 Sparrow 3 radar-guided missiles and was powered by 2 General Electric J-79GE-8 engines. Like the McDonnell F-101 Voodoo, the XF-4H-1 had its engines positioned low in the fuselage. This configuration allowed maximum internal fuel capacity and efficient air intake through fixed geometry intakes or intake ramps. This rectangular plate-like device in the engine's air intake was designed to generate shock waves to aid the inlet compression process at supersonic speeds. Further, the design featured a thin-section wing with a leading-edge sweep of 45 degrees with jet flaps to enhance its handling at low speeds. Wind tunnel testing revealed lateral instability, prompting McDonnell to angle the outer portion of the wings by 12 degrees instead of redesigning the titanium central section of the prototype. Adding up, McDonnell also incorporated the dogtooth or leading-edge extension to the wings to increase control of the aircraft at high angles of attack. Before its maiden flight, the F-4H prototype was fitted with the AN/APQ-50 radar to fulfill its all-weather intercept capability and a redesigned landing gear to withstand landings with a sink rate of around 23 feet per second. In early May 1958, the aircraft made its first flight before entering the Navy's competition against the Chance Vought F-8 U-3 Crusader aircraft. Due to its innovative 2-seat configuration, McDonnell's aircraft was awarded the contract. Initially, the design would be named Satan or Mithras, before being officially baptized as the Phantom II upon entering service with Fighting Squadron 121. Production for the aircraft officially began in early 1963, with initial deliveries for the U.S. Navy, with the Marine Corps and Air Force behind. The acquisition of the Phantoms by these two branches would become a direct consequence of Defense Secretary Robert McNamara's initiative to standardize the fighter aircraft across all branches of the American military. This effort was significantly propelled when an F-4B model triumphed over the Convair F-106 Delta Dart during the Operation High Speed competition. In January 1962, the USAF, adapting this model to their needs, borrowed two F-4Bs from the Navy, designating them temporarily as F-110A. This adaptation process led to the development of specific requirements for a version better suited to the Air Force, which, unlike the Navy's primary focus on air-to-air roles, would fulfill dual roles, both as an air-to-air and air-to-ground fighter bomber. Following McNamara's policy of unifying aircraft designations in September 1962, all Phantoms were redesignated, with the Navy version becoming the F-4B and the Air Force version the F-4C. The inaugural flight of the first Air Force Phantom on the 27th of May 1963 notably achieved speeds exceeding Mach 2. The differences between both variants obeyed the service's needs. For instance, the F-4B was equipped with J79GE8, 8A and 8B engines, while the F-4C initially used the J79GE15 engine, which was later upgraded to the J79GE17. Regarding radar, the Navy's F-4B used the Westinghouse APQ-72 radar, whereas the F-4C was initially fitted with the AN/APQ-100 radar before being upgraded to the AN/APQ-109. Armament was also different. The F-4B could carry AIM-9 Sidewinder missiles, while the USAF's F-4C could carry both AIM-9 Sidewinder and AIM-7 Sparrow missiles. This was due to the F-4C's greater emphasis on the air-to-ground role, with the ability to carry a broader range of bombs and ground attack munitions compared to the Navy's F-4B. Late variants, such as the F-4J, would enhance the Phantom's air and ground attack capabilities due to the inclusion of the ANOWG-10 radar, turning it into the first fighter in the world with look-down, shoot-down capability. Additionally, the F-4J featured a new engine, the J79GE10, which drastically increased performance. Another variant, the F-4N, featured smokeless engines, AWG-10B radar with digitized circuitry, and the Honeywell AN/AVG-8 visual target acquisition set, the world's first operational helmet sighting system. Overall, the two-seat aircraft had a length of 63 feet, a wingspan of 38 feet, a width of 27 feet, a height of 16 feet, and a gross weight of around 41,000 pounds. Performance-wise, the Phantom II could achieve a maximum speed of around 1,400 miles per hour, a cruising speed of 590 miles per hour, a climb rate of 41,000 feet per minute, and a service ceiling of 59,000 feet. Throughout its career, the Phantom II set several records that remained unbroken until the introduction of its iconic F-15 Eagle in the mid-1970s. On December 6, 1959, Commander Lawrence E. Flint Jr. flew the second YF-4H-1 Phantom II, reaching a world record altitude of 98,557 feet as part of Operation Top Flight. This surpassed the previous record of 94,658 set by a Soviet Sukhoi Tu-43-1. In May 1961, as part of the 50th anniversary of naval aviation, several Phantoms flew across the U.S. in under 3 hours, with the fastest of them completing the trip in under 3 hours with an average speed of 870 miles per hour. This aircraft was flown by none other than future astronaut Lieutenant Richard Gordon. In August of the same year, a Phantom II achieved a speed of around 900 miles per hour over a 3-mile course while flying below 125 feet as part of Operation Sageburner. Late in November 1961, a modified Phantom with water methanol injection set another record after over a 20-mile-long two-way course, while flying 1,600 miles per hour during Operation Skyburner. On December 5th, another Phantom II achieved a sustained flight altitude record of 66,443.8 feet, followed by another triumph. All these world records were achieved due to the Phantom II's unique design, which blended aerodynamics and firepower in a single package. For instance, the F-4 Phantom II was one of the first fighter jets to feature twin engines. This improved safety, allowing the aircraft to continue flying even if one engine failed. As expected, this twin-engine setup also contributed to the Phantom's impressive performance, especially in speed and climb rate. This feature was the key to all the world records achieved by the Phantom II in the early 1960s. Another reason for the aircraft's success was its multi-role design, tailored to various missions that spanned air superiority, ground attack, surveillance, and electronic warfare operations. This versatility made the Phantom II a valuable asset for Navy, Air Force, and Marine Corps personnel throughout the fighter's active service. By the time the Vietnam War began, the Phantom's rugged construction would be put to the test, allowing it to survive battle damage and return safely to base after intense combat encounters with the North Vietnamese. Interestingly, the Phantom II had no built-in gun design. The fighter relied on its missiles and external gun pods for air-to-air and air-to-ground combat. Although controversial, this provided the Phantom II with a sleek aerodynamic profile. For air-to-air engagements, the fighter could carry up to 9 missiles in hard points, including AIM-7 Sparrow radar-guided medium-range missiles and AIM-9 Sidewinder heat-seeking short-range missiles. For ground attack operations, the Phantom was armed with AGM-65 Maverick guided air-to-surface missiles, AGM-62 Walleye guided glide bombs, and Mark 82 and Mark 84 conventional bombs used for precision strikes. By the time the American military was fully deployed to Vietnam, newer versions of the Phantom II, such as the E model, featured an internal 20mm Vulcan rotary cannon capable of firing over 6,000 rounds per minute. The slogan "Speed is Life" encapsulated the Phantom's most significant advantage in combat. The F-4's powerful engines rapidly accelerated, enabling skilled pilots to engage and disengage from air combat at will. Furthermore, the Phantom's ability to quickly gain speed allowed it to dictate the terms of engagement against enemy MiGs. In a dogfight, the F-4's strategy often used its speed advantage to break away from the enemy and re-engage on its terms, thereby overcoming the enemy when it wanted. The Phantom II faced both successes and challenges during the Vietnam War. While it achieved numerous air-to-air victories, it also encountered threats, especially in anti-aircraft fire and surface-to-air missiles. In Vietnam, Phantom II crews from the Navy, Marines, and Air Force claimed over 280 victories, turning it into the most successful American aircraft of the conflict. Nonetheless, such triumphs came at a cost. Around 528 F-4S were lost at the hands of the enemy as it received more anti-aircraft emplacements from Soviet and Chinese allies. Despite this setback, the F-4 Phantom II became one of the most extensive post-war programs in the U.S., with 5,195 aircraft built. Of these, 2,874 went to the USAF, 1,264 to the Navy and Marine Corps, and the rest to foreign customers. The outstanding performance of the Phantom II earned it global praise, with countries such as Australia, Germany, Egypt, Greece, Spain, Israel, Japan, Turkey, and South Korea, among many others, incorporating the fighter into their air forces. It had a global presence, serving in multiple roles across different countries. Its adaptability, speed, and combat capabilities made it a significant aircraft during the Cold War and beyond. The Phantom II had a long and celebrated career, but by the late 1980s and early 1990s it was gradually phased out from frontline service in many air forces. The Phantom's limitations became apparent as newer aircraft with more advanced avionics, stealth capabilities, and better performance entered service. Its lack of inherent stealth and aging systems made it less competitive against modern threats. Some retired Phantoms found new life as reconnaissance platforms. Their large airframes allowed for extensive sensor installations, making them effective surveillance assets. Other Phantoms were converted into target drones for training purposes. They provided realistic targets for missile testing and air-to-air combat exercises. Other air forces continued to use the Phantom in specialized roles, such as electronic warfare or as aggressor aircraft, simulating enemy fighters during training. Nonetheless, the Phantom II left a lasting impact on aviation history. Its twin-engine configuration inspired aircraft such as the F-15, F-16, and Eurofighter Typhoon. Other American aircraft, such as the F-15E Strike Eagle, F-35 Lightning II, and the Hornet, were also based on the Phantom II's multi-role capabilities, proving to be versatile aircraft for different combat operations. The F-4 Phantom II's design principles and operational experiences continue to shape modern fighter aircraft, ensuring its impact remains significant even decades after its service.